In my last video, I discussed the project section of your resume and how to make it stand out to the recruiters and the interviewers. After uploading that video, I came across a project that I think is an excellent example of what a good resume project looks like. Let's watch the video together and discuss why a project like this is a good one to have on your resume. As a side note, I noticed that in the comments section of that video, people were a bit discouraged by it because the author kind of portrayed themselves as a junior developer, and that project is relatively difficult to do. If you're one of those people who feels discouraged about it, stay till the end of this video and we're going to talk a little bit about that.
I've been feeling quite a bit stuck at my programming adjacent day job lately, which led me to the misadventure known as the software job hunt in year 2024. So to prove some basic computer literacy and add yet another non-consequential project to my resume, I embarked on a quest to make a multiplayer browser game. By the way, the game is already available, source code up to the end of this video too, so check it out if you want, or stay to watch how I made it.
Right away, this project has at least 3 things going for it. For one, it is documented in a video, so you could see the whole process of how it was built. For 2, you could play it online, so it's hosted, you don't have to run any commands, install anything, it's ready to go. And 3, there's a repository with the source code. A recruiter reviewing your resume for the first time is not going to have to figure out how to run your project. They can just go straight to this video and find out everything they need to know about this project, and they could navigate to a URL and play the game. This is very important for making the first impression. And the same thing goes for technical interviewers. They're going to have a much easier time figuring out what's going on and kind of get introduction to the project, so it'll be very much easier to talk about during the interview.
Basic idea is one-on-one turn-based tactics game played on a 2D grid where players move their tanks around the board and try to shoot the opponent. Instead of squares, I'm going to use the clearly superior hexagonal grid. And I want to limit players' field of view to some radius around their vehicles to add a level of uncertainty. The map will also shrink as the game progresses to prevent players from stalling. About the graphics for the game, I decided to go with the pixelated isometric aesthetics. I like this style, and some time ago I made a simple 3D renderer and some low-poly desert theme models.
Great start so far, introducing the game and talking a bit about the artifacts that are going to be used throughout,
which I then use to generate sprites for the game. If you don't know what sprites are, they are a series of images that you can alternate to create an illusion of movement. The client side of the game will work in the language of the browser, JavaScript, but because I don't want to succumb to a vast pile of reference errors, I'm going to write it in TypeScript. For that, I will use the Canvas HTML element, which provides an API to draw shapes, text, images, or even 3D scenes onto the screen. And for the server side, I'm going to use the Google's Gopherlang. I'm not going to use any frameworks or game engines, because I'm doing it more for the process of doing than anything. But I'm going to use Gorilla WebSocket library, which at the moment is the de facto standard WebSocket implementation in Go.
I'm not a game developer and I'm not necessarily a front-end developer either, but if I saw this project and I was to interview this person, this is great. Like, thank you for talking a little bit about your stack choices and talking about how the images move. Like, that stuff is not necessarily obvious to everybody.
So to start off, I opened my favorite editor and began to work on making the canvas responsive so that game keeps resizing with the window and doesn't get blurry when user has non-standard device pixel ratio. Next, I worked.
Another great technical detail about the responsiveness of the game in a web browser. It's important because whoever is interviewing you may not be a front-end developer, so that helps. They might be an engineering manager, they might be a back-end developer, you never know.
The canvas. Canvas provides you with a draw image function that basically copies a fragment of some image and pastes it into a specified area. So beforehand, I packed all my sprites into a single PNG file and prepared a long list of start, size and offset values for each of them so that I can copy them out, use the offset to align them to the grid, and construct the map one element at a time, repeating this process on every frame. Next, I added the first bit of interactivity, dragging them up, which is not too complicated and involves using just a single vector for offset value. With that, some elements of the final architecture started to clear out, with GameState object holding all the game object information as plain data, display driver drawing them, and game instance managing it all. Next piece of the puzzle will be grid component that will manipulate game objects based on user actions and server messages. After implementing dragging, I worked on zooming. The sprites must be scaled by natural numbers to keep them pixel perfect, which means the initial zoom would give a 100% jump in size. That's why I prepared sprites in two base sizes, 64 and 96 pixels, so that by interleaving them I can obtain smoother jumps. So far, when implementing dragging and zooming, I only worked with screen coordinates. But to manipulate tanks, I need a way to translate between coordinates on the screen and coordinates on the grid. This was a little bit harder than I expected, and I was glad to come upon this nice website dedicated exclusively to hexagonal grids. With that, I was ready to begin tank navigation system. Users can perform two actions with a tank, either moving it or shooting in one of the 6 directions. Moving is carried out by pressing on the tank and dragging to a different axis, and shooting by pressing it down for a tiny bit longer and releasing on selected direction. Range of a single move will be limited to some value, so players don't traverse the whole map in one turn, and same will be for the range of a shell. After that, I started working on adding 2 more features. One is limiting players' field of view or fog of war, so that players can only see action happening inside some radius around their tanks, and the distant parts of the map are darkened out. The second feature is drawing markers indicating cells that tank is allowed to move into, with regard to the current path and obstacles. It will be actually 2 different markers, green one taking neighboring tanks into account, and the yellow one ignoring them. Both can be calculated with a simple breadth first search. Then I began working on the UI system. To display buttons on canvas on screens with different sizes and aspect ratios, I will need some substitute for CSS grid. I came up with an idea of invisible panels that will be resized and realigned on every change and will act as an intermediate grid for UI elements. They will be defined in 2 variants for vertical and horizontal screens. Implementing buttons from scratch is trickier than you might think, because in HTML DOM or UI libraries, you usually work with complete events like click or hover. But in this case, the buttons are just some painted area of canvas, so I will have to work my way up from simple primitives, pointer up, pointer down, and pointer move. And clicking a button isn't pressing a mouse on it, but rather releasing while hovering. And it's by design because it makes the action cancelable by moving the cursor up.
Notice how the video author is not just throwing technical details at you, he's actually building up a story and kind of sprinkling the complexity on top, which makes the project and the video like a journey. It makes it more interesting to watch.
Please. It gets more complicated with both the game area and the UI. We don't want to trigger the button when we are navigating the map, and likewise, we don't want the grid to respond to our mouse drag when we interact with UI. So I added some basic in-game buttons and a main menu, in the result adding 2 more components to client architecture, the UI system drawn by display driver, and the notifier that will pass button and other game events from UI and grid to game instance. Up next was finally writing some server-side code. I set up a file server to serve static files and a WebSocket endpoint. For now, I wanted the server to receive players' intended moves, resolve them, and send back the results to client. Of course, I could write my own binary message format, but I'm going to keep things simple and just use the omnipresent JSON. The WebSocket driver object on the client side will be responsible for exchanging the messages and notifying game of any updates. As you can see, the system takes collisions into account and correctly resolves them. As you can also see, the frontend is devoid of animations right now, and final result is displayed instantly on the map instead. I will tackle that later because I'm going to implement shooting first. For that, I again need to touch server-side code. add some constraints for how far can a projectile fly, check its path for any buildings and tanks, and if there are any, stop it early, and if it destroyed something, tell that to the client. What I also need is tracking each tank's visibility. Without that, everyone could have a wall hack and see all the opponent's moves on the map. And here's the result. Not only tanks can drive, but they also get destroyed when hit now. Enemy vehicles in the shadow stay invisible, but still no animations. So let's do that now. The animations are probably the most math-heavy part of this game. They also add a lot of unexpected complexity, because now I need to track time, correctly rotate tanks, turrets, interpolate positions. Also, the movement itself may be as complicated as you want. You can keep it simple with constant speed and sharp corners that will only involve some simple vector interpolation, but you can also run the path a little bit and add acceleration on start and finish to make it more natural, or even add acceleration mid-drive to prevent weirdly fast corner entrances. Working with acceleration and distance will involve integrals, but in this case it's just calculating areas of triangles. Here's the final result. Movements look pretty smooth. I also added explosions and smoke from the cannons. These are just sprites too. I have 2 player matching modes in mind.
Nice, that looks really good so far.
I have 2 player matching modes in mind for this game. You can create or join your private room with a code, or you can enter an open room and get matched with a random player. Getting the code from players on desktop would be easy. We could just register the keystrokes, but I want mobile compatibility. How do I take input from mobile player using just canvas element? Custom virtual keyboard is an idea, but that's complicated. So I'm going to cheat a little bit and introduce an actual HTML input element into the game and style it to blend nicely. That breaks my abstractions a little bit, but it is what it is. At this point I was quite surprised it all works so well together, and started the hardest challenge of this project, namely the actual server-side logic for real multiplayer. Because I'm writing it in Golang, I decided to abuse channels for the player room hub communication. What I got was a pretty messy maze of channel connections where I had to track which of them guarantee reads and which do not. I added state machines to make this mess more manageable and spent some time looking for possible coroutine leaks. The resolution of players' actions also changed somewhat, with input from 2 players that needed handling now, and while the logic might seem pretty simple, there's a lot of checks I have to perform to validate the actions. Just for the move action, I need to check if the path doesn't overlap, I need to check if the tank won't be blocked by other tank or a building, or it doesn't go through empty space. I need to check if path is continuous, if it doesn't exceed allowed range, if the tank is not already destroyed. And I need similar checks when validating tank shots, and also need.
Notice the layers of complexity being built up in this video. This is actually a great reason to have a video, so you could kind of tell a story of building a project, because just posting the code, people are unlikely to read through your commit history and try to figure out like what challenges you had to overcome during the implementation of the project.
Checks when validating tank shots, and also need to account for visibility between players. So there is a lot of bug potential here. There is also a lot of room for optimization too. Some loops may be redundant, some things could be represented as bit masks, but that's not today's concern. Writing this core multiplayer logic is a big milestone. Of course, it's not production ready yet, but the important thing is that 2 users can now play a game between them on 2 different devices. At the start of the video, I said that map will shrink throughout the match, and I haven't done that yet. Each game config will have a predefined shrinking rate, causing every hex and tank in some radius around the center to dissolve. Otherwise, players could drive around the map forever without ever engaging in a fight. By the way, so far I had neglected handling other messages from servers, such as room or server disconnecting, or even the final result, so I tackled that as well with a new model-like UI element. I also refactored the game class a little bit because the complexity was getting the best of me. The game still lacks any sounds, and I'm not going to create a soundtrack, but some sound effects, especially explosions, would be desirable. So I pulled some MP3s of a German Leopard tank and explosions from Zapsplat, pushed some random buttons in Audacity and saved them as a single MP3 file. I then encountered the audio context JS API for the first time, which was not too intuitive at first. Anyway, I managed to put it to use, hopefully without causing any memory leaks. Almost done, I added the last finishing touch, explosion shake. I remember seeing a video explaining using sine waves to simulate wobbling of the tree under the wind in some game once, and I thought it can simulate ground shaking from the explosion as well. The idea is to take a sine function, transform it with some random coefficients, repeat for a couple more, and sum them to get a rather random looking wave. Then make a second one and clamp them so they start and end at 0 and map as x and y coordinates on a 2D surface to get a shake. And with that, I'm going to wrap it up.
Again, another really good example of explaining a bit of a complexity behind seemingly trivial detail of like the ground shaking from an explosion and showing the math behind it. Not something you can easily showcase via a README or some other text documentation. So it really highlights why a video can really add to your project.
And with that, I'm going to wrap it up. I linked the GitHub in the description. I also deployed the game and you can play it at 10 cops XYZ. To make that happen, I added some things that are out of the scope of this video. For example, OAuth2, persistent DP, rate limiting, landing page.
If you recall, in the last video, we talked about how production projects are just so much more impressive than non-production projects. And this is like an example of that because like the database choice, the rate limiting, the authorization, all of those things you have to figure out for a production project. And that looks really impressive on your resume because in real world software engineering jobs, you are going to be working with live production projects.
Quick tutorial, single player mode, more explicit markers on tanks, HUD with game information and GitHub-like avatars, rotating tank in the main menu, speed up button, ping gesture for zoom on mobile, and probably some more smaller things I forgot about. But let's talk about what I did not do. I don't own any Apple devices, and it came as a surprise when I tested the game with my friend on his iPhone, and it got disconnected on every window change. Turns out that iOS aggressively throttles WebSocket connections in the background. I tried to make a not very reliable workaround by reconnecting on the client side after WebSocket close event and sustaining player's session for some period on the server, but surprise surprise, the iPhone closed the connection in a pretty unreliable way with different exit codes, different delays after resuming Windows session, so this hack went out the window. The correct way of handling that would probably be to preemptively close and open WebSocket connections on every window visibility change, but that would mean rolling this out for everyone because there isn't a reliable way to deduce a client's browser, and that's a worse UX for many users that do not require this solution. I might give it some more time in the future, but I will see. For now, thanks for watching.
At the end, the author talks about all the unresolved challenges in a project, and this is a good section to include in a video like this because any, again, real world project in production is going to have tech debt, is going to have bugs, is going to have nice to have features, and it's always good to talk about those challenges that remain unsolved. Overall, great video, great project. Putting on my interviewer hat, I did notice some things that I wanted to point out. First thing I noticed reviewing their repository and their source code is that they're missing an about section here. And then I went down to the README, which is okay. There is a README. There's a link on where to play the game, but I'm not sure what this means up to this point where the screenshot is. And usage section is great to have, but there is no contributing section. This is really, really key to have when you read me. How do I contribute? Are contributions even welcomed? Because we could see here that people are forking this repository. Are they even allowed to fork the repository? There's no license anywhere. Am I allowed to contribute to this? There are pull requests here. They look to be mostly unaddressed, if not completely ignored. Then when we navigate to the issues, I also see some unaddressed stuff here. Not really sure if this is intentionally unaddressed. I would definitely have some follow-up questions about the repository and why there's unaddressed pull requests issues, and the README doesn't have contribution section. There's no license associated with this repository. If that's intentional, that's fine. It just needs to be preferably clarified that, hey, I'm not taking any contributions. This is just to showcase the code, but it's not meant to be extended, forked, and so on. As promised in the beginning of the video, I wanted to circle back to the comment section. The title of this video indicates that the author of this project is a junior developer. And as a result, a lot of people in the comments are freaking out about the situation. Like, how am I going to build a project this impressive to put on my resume? And I really have two thoughts about this. One is not every stack is going to be familiar to you. Like, you might not be into making video games. Like, I'm not into making video games, so this project seems nearly impossible for somebody like me. And that's okay, because I wouldn't even attempt to build something like this because it's not within my interest spectrum. I would definitely pick something different in a different stack. And the second point is the author of this video likely has some experience with building projects like these that led him to choosing this in the first place. Probably has some interest in video games, browser-based video games, and there was a lot of learning that was skipped over in the video because the video doesn't show you the long debugging sessions, being stuck on something, the learning process, like how many days, months, or years have gone into researching these things, and what it took to understand all the pieces that went into this project, like the database choice, authorization, SQLite, TypeScript, Go. There's just so many pieces that had to be learned, most likely individually, before this project came about. In the end, I want to leave you with this. Junior developer as a term doesn't have a whole lot of meaning. It is different between different companies, and based on your interpretation, it could mean many different things. Use this project as an inspiration, as an example of what a project in a project section of your resume should look like. Start simple, start small, build your project over time, and document the journey as you do it.